This lecture we will see how to condense or eliminate certain rows and columns of a set of linear algebraic equations. Basically, we reduce the number of unknowns. Let us say we have a linear system of 4 algebraic equations with 4 unknowns, but using a calculator we can solve a system of equations with only 3 unknowns. So is it possible to solve a 4 unknown system using calculator which can only solve 3 unknown problem? Yes, the method is called condensation or elimination. How to perform this operation is what we are going to see in this lecture. Consider a linear system of 4 unknown equation. This is some example of 4 unknowns from the structural mechanics problem I have taken, and the unknowns are u1, u2, u3, u4, and there is a right hand side with a common multiplier, and the coefficient matrix also has a common multiplier. Say we want to reduce this system of unknown equations to 3. Then if we want to eliminate the 4th unknown and retain the u1, u2, u3, then mark the 4th row and 4th column. This 4 will be the pivot row and pivot column. It looks something like this. The 4th row is marked, the 4th column is marked. These will be the pivot row and pivot column. And similarly, if you want to eliminate the second unknown, that is u2, you can mark the second row and second column accordingly. Okay, so this is the system of linear equations with the pivot row and pivot column marked. So there is a let us say I want to modify the element in the third row and first column, minus 15. This has to be subtracted, a value has to be subtracted from this element, so that we will get a modified system of equations with only 3 unknowns. So how to do that one? In the considered example, the third row first column whose value is minus 15, this has to be modified. For that, the corresponding elements in the 4th row and the pivot row and the 4th column, the pivot column values are 0 in the pivot row and 5.76 in the pivot column. Okay, so these two are to be multiplied and divided by the pivot value, which is 24.32. okay, like this. This is the element in the pivot column, 0 is the value or the element in the pivot row, and the pivot value is 24.32. So I have to multiply 0 with 5.76 and divide with 24.32. That product, the term, should be subtracted from minus 15. So minus 15 is to be replaced with minus 15 minus product of 0 and 5.76 divided by the pivot value. So here the value remains same because one of the pivot values is 0. Okay. Similarly, we have to modify all the elements of the remaining part of the matrix. Okay. So for example, this value at the first row first column, 22.68, it has to be subtracted, a value has to be subtracted. That value is obtained by multiplying the corresponding element in the pivot row and in the from the pivot column, this, and divided by the pivot value, like this. So the element 11 will be subtracted from the element 11. We subtract this term, 0 into 0 divided by 24.32. Similarly, from the second element in this row, in this column, we subtract 0 into 0 divided by 24.32. From the third row, we need to subtract 0 into 5.76 divided by 24.32. Similarly, from this element, 0 multiplied by 0 divided by the pivot value. Again, this is the element from the pivot row, again from the pivot column divided by the pivot value. Again from the third row and first column, the pivot value is 0, the pivot row and pivot column, then divided by the pivot value 24.32. Again the value from the pivot row, value from the pivot column divided by the corner element, that is the pivot value. Similarly, value from the pivot row, value from the pivot column, multiply them, divide by the pivot value. Similarly, for the last element, pivot row multiplied by pivot column divided by 24.32. You can see that in all the other places, because of the values are 0 in the pivot row, you get the same values, there will be no modification. But in the last term, the third row, third column, you have a non-zero subtraction, so only this term will change. On the RHS also, right hand side of the equation also, the values are to be modified by subtracting the value from the pivot row multiplied by value from the pivot column divided by the pivot value. Again, for the second row of RHS, multiply by pivot row, pivot column, and the corner value, which is the pivot value. Then again from the pivot row, pivot column divided by the pivot value. So you got all the terms are modified by subtracting with a term. So it looks like this, the final form, and you can see most of the values will remain same because of the multiplication with the 0. So the final equation will be, the 3 by 3 equation will be 22.68 has not changed, minus 5.76 has not changed, minus 15 has not changed. Similarly, all these terms have not changed except this value in the third row, third column. There is a change from 22.68 to 21.31. Now this should be u1, u2, u3 is equal to 50 times 1 minus 2, 0. So you will get u1, u2, u3 as this one. You can solve using your calculator. So this is how we solve the reduce the 4 by 4 equation to a 3 by 3 equation. Similarly, if you have to eliminate multiple rows and of course columns, in this case the pivot row will be a matrix, pivot column will also be a matrix, and the pivot value will be also a matrix. So instead of multiplying numbers, here you have to multiply and divide with matrices. So let us say we wish to eliminate 2 rows, third and fourth rows, and third and fourth columns. Then mark the third and fourth rows and third and fourth columns of this equation, and this will be the pivot row now, and this will be the pivot column, and this will be the pivot value. These are the matrices. You can partition this matrix into portion A, which is to be modified, the portion B, which is the pivot column, the portion C, which is the pivot row, and the portion D, which is the corner or the corner matrix or the pivot matrix. So this is on the RHS also, the retained values will be 1 and minus 2. This portion is E, and the pivot row is F. So this becomes in the partitioned form of this equation, A, B, C, D multiplied by U retained and U eliminated. Okay, these are the unknowns which are retained and unknowns which are eliminated, is equal to, on the right hand side, E and F matrices are there. So if you apply the condensation here, you have to multiply, you have to modify A by subtracting this term B into C divided by D. In matrix form we write it like this, B into D inverse into C. If it is a scalars, just multiply B into C divided by D. If they are matrices, you have to write B into D inverse into C. The order of the matrix, the order in which we conduct this operation is important. You should not reverse or make any changes in this order. Similarly, on the RHS also, the E the E matrix will be modified by E minus B into D inverse into F. Instead of C, there will be F here. So the same thing you can see here. This is the expression that we have to evaluate. So A is this matrix minus B matrix, this B matrix, the pivot row, minus D inverse, this pivot matrix inverse into C. Okay, U1, U2. On the right hand side also, E minus E is this value 1 minus 2 minus B is minus 1500 minus 15000 into the pivot matrix inverse into F matrix. Since this is 0 0, here all the values will be 0 and the RHS will remain 1 minus 2 only. There will be no change in this RHS. Similarly, on the LHS, if you do this operation, you will get a matrix like this. Okay, so this minus this operation, once you find the inverse of this 2 by 2 matrix, you will get this, and after multiplying the inverse with the second term, the third term, you will get this expression, and on further multiplication and then subtraction, you will be getting this modified 2 by 2 equation, which you can easily solve even by manual methods, and you can see that the results are same as that we got with the with 4 unknowns or with 3 unknowns. The same results you got even with 2 unknowns. So this is the process of eliminating the additional unknowns which we don't need.